बिस्मिल्लाहिर्रहमानिर्रहीम रब्बी शरह ली सदरी वयस्सिर ली अमरी वाहलुल उक़दतम मिन लिसानी यफ़क़हू क़ौली रब्बी यस्सिर वला तुअस्सिर वतम्मिम बिल खैर सल्लल्लाहु अलैहि वसल्लम सल्लल्लाहु अलैहि वसल्लम सल्लल्लाहु अलैहि वसल्लम. Assalamu alaikum students. We are going to start our new topic, that is deformation. Before going to start deformation, we have to know what is deformation is. Deformation is change in shape due to an applied force. This can be a result of tensile pulling forces, compressive pushing forces, shear bending, or torsion or twisting. Two types of deformation is there: elastic deformation and plastic deformation. Elastic deformation, this type of deformation is reversible. Once the forces are no longer applied, the object returns to its original shape. Then we have plastic deformation. This type of deformation is not reversible. However, an object in the plastic deformation range will first have undergone an elastic deformation, which is reversible, so the object will return part way to its original shape. Then we have elastic deformation. We have to plot and draw the interpret extension load graph for an elastic solid and describe the associated experiment by the using experimental procedure. What is the aim of the study for that elastic deformation? That is study the deformation of spring. The apparatus we need, that is a spring, 100 gram slotted mass, meter rule and retort stand. What is the procedure for how we can get the value for the elastic deformation? First of all, arrange the apparatus as shown below. Measure the length of unstretched spring. First of all, no weight is there. You have to measure the length. Let's suppose we have a 10 centimeter. Measure the length of the stretched spring as a mass is added. Let's suppose we added a 2 masses over there. Its length increased from 10 to 20. So repeat this procedure twice or thrice to get the accurate value. That is the calculation. The load for every mass, that is 100 gram, is founded by using W is equal to mg. The extension of spring is difference between its stretched and unstretched lengths. Here we have a 3 springs. One is unstretched. Second one we having a 1 Newton weight over there, and third one we have a 2 Newton weight. Look at that beta. In the first we have a 10 millimeter extension. In the second one we have 20 millimeter extension. Means by increasing temperature, increasing the load, we have increase in its extension. But that is the graph we plotted against load and extension. On the x-axis we have a load, and on the y-axis we have extension. The graph is divided in two parts. The graph slopes up steadily. The extension increases as the load increase. Till the cross x, we have the graph is moving steadily. Means the object can reverse back to its position at that point. But when the graph start becoming in a round shape, it means the graph bends. Load is a greater, the spring become permanently damaged. Mean it will not come back to its original position. That is called the limit of proportionality. What will be the conclusion? The line is straight and passes through the origin. It means every 1 Newton increase in the load produces the same extra extension. If the load is double, extension is doubled, and extension or load always have the same value. Then elastic deformation, how we can distinguish between the limit of proportionality, how to recognize the significance term limit of proportionality for an elastic solid. Here a graphical representation is there. On a x-axis we have a length, and a y-axis we have a force. The yellow one region, the region where the extension is proportional to the force applied. A returns to original form where force is removed. When the force removed, it will come back to its original position. The white one, we have an elastic limit. Elastic limit of a spring is a maximum stretching or compressive force that can apply to a spring before it loses its elasticity. And the blue one, that is plasticity, means a region where any further extension would not cause it to return to its original form. Then we have a Hooke's law, which can obey the law of deformation or elastic deformation and plastic deformation. Hooke's law states that extension of a spring is proportional to the load applied to it, provided the limit of proportionality or elastic limit is not exceeded. In terms of equation, we have F is equal to Kx, where F is the applied force, K is the stiffness of the spring or the spring constant, and X is the extension of the spring, means how much spring can extend. That is all about from your topic deformation. Good luck.